All right, so this is part 2 of the Unit 3 test from Ms. Metter, questions 11 through 20. Bear with me because I just did this whole video for like 45 minutes to an hour and it did not save. So back to square 1, or square 11 I guess I should say, even though we're not doing squares, we're doing circles and ellipse. So it wants to choose the graph. Notice that it's an x squared plus a y squared. So the standard form for an ellipse is x minus h quantity squared over some number plus y minus k quantity squared over some number equals 1. Now, it looks like up here that x minus 4 squared is not over anything, but technically it's over 1. So your bigger number is your a. So 9, so this time a squared is going to be underneath y. It always goes with the biggest number. So that tells us that y is the major axis here. Y is major. So it's going to be bigger in the y direction, okay? So the center of this circle, the center is, sorry, of this ellipse, I apologize, it's going to be h comma k. All right, and inside with x is what takes x's place, which is your h, and whoever's inside with y is your k, because that's in y's place. Remember, when you bring it out of the parentheses, it has to change sign. So even though it's minus 4 in the parentheses, it's positive 4, and even though plus 5 is in parentheses with y, it's minus 5. Let me try to do a little bit better. 5. So my center is at 4, negative 5. So just from that, 1, 2, 3, 4, 1, 2, 3, 4, 5. Our center should be down here. And y is the major axis. So first of all, I know this is not the center. This is not the center. It looks like B and C both have a center of 4, negative 5. But we need to go, A is the distance from the center to the vertex in the major direction. So A is the square root of 9 because A squared was 9. So A is going to be 3. And that's going to be in the y direction because y is the major axis. All right, B squared was 1. So B is also going to be 1 because the square root of that is 1. That's going to be how far you go in the x direction. So you're going to go 1 left, 1 right in the x direction, but up 1, 2, 3 in the y direction. 1, 2, 3 in the y direction. So your ellipse should look like that. So the answer is B. Okay, next number 12 is going to be the equation of a circle. Remember, for a circle, it's going to be in this format: x minus h quantity squared plus y minus k quantity squared equals the radius squared. All right, so it does not equal 1. So your h and k are going to be your center. And remember, it's equal to the radius squared, not just the radius. So everything is squared. X is squared, y squared, the radius squared, even though it is a circle. So our center is at 0, 0, so nothing's going to be attached to x or y. So we just have x squared, y squared. So x squared plus y squared equals the radius squared, so not 7, but 7 squared, which is 49, and that is the answer to number 12. Okay, number 13. We need the equation of a circle. So remember that a circle, let me take that off, that looks like center. The equation of a circle is going to be x minus h squared plus y minus k squared equals the radius squared. Everything is squared even though it's a circle. So this is my h and k. You need to be very cautious because when you take something out of parentheses or put it in the parentheses on these problems, you change the signs. So h is negative 5, but we're going to put plus 5 over here with x. And y is negative 1, but we're going to put plus 1. So we got the easy part, all right, the center of the circle. Now, it doesn't give you the radius of times. It tells you a point that the circle passes through. So let's do a little rough sketch over here. We got negative 5, 1, 2, 3, 4, 5, negative 1. That's the center. And then the circle's going through the point negative 2, 1, which is here. So the radius is this distance. That's your radius. So I'm going to teach you the easiest way I know how to do this. All right, I'm going to draw a right triangle. All right, and I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, to find the radius. Now, in this problem, in the Pythagorean theorem, c is always the hypotenuse. So your radius is the hypotenuse, so that's c squared. You just got to find out the two sides of this triangle. So from here, let me use blue here, from here to here, how far is that? Well, this was at negative 5, and this x value was at negative 2. That is a difference of 3. So we'll call A 3, and we're going to square it. All right, now we want to find the distance of the triangle on this side from here to here. And we were at negative 1, we went up to positive 1, so that distance is going to be 2. All right, so that's going to be 2 squared, and that's 9 plus 4, which is going to be 13, which is not the radius, but it's the radius squared. Now, what do we really need the radius in this problem, or do we just need the radius squared? Just the radius squared, which is 13. Now, I do want to show you another option for doing this problem. You could have used the distance formula. Some of you maybe recognize the distance formula, some of you maybe don't. It's x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and you're taking the square root of all of that, okay? Now, your x, this is your first x and your second x, your first x, your first y, your second x, and your second y. You want to subtract the x's and then subtract the y's. A lot of people get that mixed up. That's why I prefer drawing the triangle. The distance formula comes from the Pythagorean theorem. You might recognize it here in just a second. So the second x was negative 2 minus the first x, negative 5. Second y was 1 minus the first y, negative 1. Okay, you could type everything under the radical, not with the radical. You could type all that in the calculator, but I'm gonna just do some old school math because it's gonna show you where this comes from over here. So now, negative 2 minus the negative is negative 2 plus 5. That's 3 squared. 1 minus negative 1 is 1 plus 1, which is 2 squared. Notice that's what we had over here. 3 squared plus 2 squared, right here and here. And that gives you 9 plus 4, which again is 13. Now, that would give you the distance from the center to the end of the circle, which is the radius. Okay, so this is the radius. But we didn't want the radius for the equation. We wanted the radius squared. So if you square that, the square and the square root cancel, leaving you with 13. So you can decide which one you want to use. Okay, question 14 wants you to find the center and the radius of the circle. This is a fairly easy question. Remember, the standard form for a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So the center is h comma k. There's nothing attached to x or y, and we're not adding anything to it, so the center is just going to be 0, 0. That's nice. Now, a lot of people mess this up. The 81 is not the radius. That's the radius squared. So to solve for the radius, you got to take the square root of both sides. So the radius is going to be 9. Now, when you graph this with the Math Excel thing, you're going to choose circle. You're going to plot the center. Okay, and then you're going to drag the circle out to how far you want it. We want it out to 9, so let's see. I think that's 9, and then it'll draw the circle in for you automatically. I'm not going to even attempt to draw that because I can't draw a circle. All right, number 15, we have a center and the radius of a circle. Remember, the circle is x minus h squared plus y minus k squared equals the radius squared. Everything is squared, even though it's a circle. So first, it wants the radius. Remember, 9 is not the radius, that's the radius squared, so you got to take the square root of that, which is going to be 3. The center, let me take those off, sorry. The center is going to be h comma k. Now remember, when you bring it out of the parentheses, it changes sign. So plus 3 is in there with x, and the x spot is -3, plus 2 is in the y spot, but when you bring it out, it's -2. So now when you plot this, you plot the center first, select the circle on the graphing tool. -3, -2 would be here for the center. And then you need to go right 3 from the center. 1, 2, 3. You need to drag your circle right there. And then it'll draw the circle in for you, and you are done. All right, question 16. Now we're switching to hyperbolas. So when you have y equals x squared, that's a parabola. That parabola is either going to open up or down. Well, that one's going to open up because the leading coefficient's positive. If you have x equals y squared, that's a parabola that opens in the x direction. Okay? Then we looked at ellipse. So an ellipse is where you have x minus h quantity squared. We'll just pick x to be the major axis here, so we'll put a squared underneath it, plus y minus k squared. We'll make y the minor, so b squared's under it. Now, what you have is you have an x squared and a y squared. So when you just have one of those squared, it's a parabola. But if you have a parabola plus a parabola, it makes an ellipse. Okay? Well, if you have a parabola minus a parabola minus a parabola, that makes a hyperbola. So there's two formats here. The one that we're looking at is in standard form where x is first. So it's x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. So you're subtracting the two, which makes a hyperbola. Now, for ellipse, a squared is always the biggest number. That's the major axis, so if a squared's under x, it's going to be bigger in the x direction, like the one I drew here, all right? But for hyperbolas, the positive one is always the bigger one. So 9 is bigger than 4. Y'all like, well, duh, 9 is bigger than 4. But technically, think of that as a -4, because on future questions, it could be 4 here and 9 here, and the x would still be the major because it's the positive one. Now I want to take those two off, where I can do my work here. All right, so first I want to find the center. The center is h comma k. So inside with x, I bring out -1, it becomes +1. Inside with y, I bring out -2, it becomes +2. Oh, by the way, since it's x is the major axis, the parabola should be doing this. So I can eliminate choice B on this option. Now let's just, where is the center of 1, 2? Well, here's the center of that graph. That's not 1, 2. All right. 1, 2. Oh, look, that's in the y direction. So the only choice here is there, because if you go right 1 and up 2, now these tick marks are by 2, so right 1, up 2, there's the center. And you know it's going left to right because x is the major axis, the positive axis. Okay, question 17. It shows you the graph of the hyperbola. It tells you the 0, 7, the points on the y-axis, the points on the x-axis. So first of all, we got to know what's what. The vertices are the hyperbola's vertex. Each parabola's vertex. So this is the vertex and this is the vertex. 4, 0, negative 4, 0. Easy peasy. Yes, I did say that, and I am very old. Anyway, the coordinates of the foci. Remember, the foci are on the inside of a parabola or the inside of an ellipse. So the inside here are these 2 points. Now, that looks like negative 8 and 8, but notice that's not a choice. We know it's not negative 4 or 4, 0, because that's the vertices. 0, 7, and 7, that's up here and here. Definitely not the foci. So it's got to be B. All right? Now, the asymptotes are in, y'all remember y equals mx plus b. Slope-intercept form. That's your slope. Slope is rise over run. The b is the y-intercept. Now, an asymptote is an imaginary line that the graph approaches and never touches. Okay? So I'm going to draw this in and then I'm going to erase it. That is the positive sloping asymptote. All right? Now, I need to know the slope of that. First of all, the y-intercept is going to be 0. Okay? So that's why down here they don't have plus 0. Okay? That'd be silly. Hey, how old are you? I'm 16 plus 0. So all we need is y equals plus or minus whatever the slope is times x. So I want to count rise over run. So up here, let me use a different pen. I need to count the rise. All right, they told me that was 7. And then the run, that's right 4. So it's a rise of 7 and a run of 4. If you were to find the slope of the blue line, the other one, I'm going to make this one blue. Y-intercept is 0, and then you would rise down 7, and then you would run right 4. That's why it's plus or minus 7/4 over here. And that's all of that one. All right, number 18. Determine the foci and the equations of the asymptotes, watch your mouth, and sketch the graph of the hyperbola. Now, first I noticed that it's x squared is the positive one, so x is the major axis. So this should be opening in the x direction. All right, x direction meaning this way and that way. So I know it's not C. That's the only one I can eliminate, okay? Well, I got a 1 out of 3 chance. Next, my a squared is 9. So my little a is going to be 3. Now that's how far I'm going to go in the x direction. I'm going to go 3 right, 3 left from the center. By the way, the center is 0, 0 because nothing is attached to x or y. Nothing's added to x, nothing's added to y. So the center is 0, 0. You don't notice the center is 0, 0 in all of these. All right. B squared is 4. So the square root of that is 2. So I want to go 2 in the y direction. So on these tick marks, they're all by 1s. I notice in choice A, it's going right 3 and up 3. That's definitely not it. B, it's going right 3. See, 1, 2, 3. And then it's going up 1, 2. That seems right. Here it's going right 2 and up 3. So it's not D. The answer's B. Okay. Let's do the asymptotes first because they're easier. So remember, we got to have y equals plus or minus mx. Plus b, but b is 0, so I'm not even going to worry about that. So let's count slope. Remember, slope is rise over run. All right, yeah, that says rise. Sure it does. All right, so from the center to that point right there, let me see if I can get a different. So from the center to that point there, I'm going to rise up 2. So my rise is 2. And I'm going to run right 3. So it's going to be plus or minus, because if I were to do the negative slope, we would go down to right 3. Now, this time they want you to type it in as 2 separate equations. Y equals 2/3 x and then the second equation would be y equals negative 2/3 x. Don't let that confuse you. All right, let's go back to foci. Foci are on the inside of the hyperbolas, so they should be ish somewhere in there and somewhere in there. Okay, they may be closer. I haven't calculated it yet. So you need to know little c. You know a squared and b squared, but I need to know little c. So the equation we're going to use is c squared equals a squared plus b squared. That is the Pythagorean theorem. I want you to note, for an ellipse, it was a squared minus b squared to find c squared. Here's how I always remember it. On a hyperbola, you're subtracting the main equation. See, look up here at the main equation. You're subtracting it. So on the c, you add a and b, a squared, b squared. On an ellipse, let's just make up one. On an ellipse, since your a squared and your b squared, since the main equation's adding, your c squared equation was subtracting a and b, or a squared, b squared. So this was for an ellipse. So notice on a hyperbola, since the original equation's minus, you're going to add the a squared, b squared. So let's do that. So a squared was 9, b squared was 4. Remember, it's already squared in the equation. So c squared is 13. We're trying to solve for c, so we're going to take the square root of both of those to solve for c. So it's plus or minus square root of 13. Let me throw that in there. Plus, minus. Now, you're going to add the c and subtract the c to the major axis, which was x. So for the foci, it's h plus or minus c comma k. Now that's only if the major axis is x. If it was y, you would do k plus or minus c. All right, so our center was 0, 0, so it's 0 plus or minus the square root of 13, comma 0. Now it wants you to write it as two separate ordered pairs. All right, so up here I'm going to write it as 0, comma radical 13. Nope, back it up. Beep, beep, beep. Sorry. 0 plus radical 13 is just radical 13, comma 0, comma, because you got to separate your ordered pairs with comma, negative radical 13, comma 0. All right, so that one is done. Okay, question 19, we have, it says use vertices, asymptotes to graph the hyperbola. Locate the foci and find the equation. So we know it's a hyperbola because they told us, but also because it has a minus. Now, caution light, we're in Crofton, all right? So a lot of people would say, oh, 36 is bigger, x is the major axis. False. 16 is actually telling me it's major because it's positive 16, whereas the 36 is negative. So the major axis is y. So it should be open in the y direction. Oh, hold up. We good? Okay. Should be open in the y direction, which would be like up and down. So which one does not open up and down? Well, A doesn't. And C does not. So it's either going to be B or D. So we got to figure out. Remember, a squared is always underneath your major axis. So a squared is 16. Take the square root, you get 4. Now that's how far we're going in the y direction. B squared is 36. Take the square root of that, you get 6. That's how far we're going in the x direction. All right, so I'm looking at B. And I need to go up 4. Now, these are by 2s. So this is 2, 4, 6. That's 6 in the y direction. That's wrong. If I go over here in the y direction, I should be going 4. That's 2, that's 4. All right, and then in the x direction, I should be going 6. 2, 4, 6. All right, so D is the answer. It wants foci and equations of asymptotes. I think the equations of the asymptotes are easier. Let's do that first. y equals plus or minus mx plus, that's supposed to be plus or minus, y'all. Lord help me. All right, plus or minus mx plus b. But remember b, it's going through the origin over here, so b is just 0, so it's gone, bye. All right, so I need y equals plus or minus whatever the slope is times x. Slope is rise over run. So you're going to count from the origin here to here, but we got to rise and run. Now remember, we counted by 2's. So we rose 4 and we ran 6. You can't leave it like that though. You got to reduce it to 2/3. So my equation is going to be y equals plus or minus 2/3 x. Now, don't forget our foci. Foci, you have to add or subtract c to it. Now, the major axis was y. So since your center is h comma k, and on our equation they both were 0. All right. Your foci, since y was the major axis, okay, we're going to add or subtract plus or minus c to the y value. Now, how do you find c? It's like it is the Pythagorean theorem. It's c squared equals a squared plus b squared. How can you remember that? The hyperbola has a minus in it, so the c squared equation has a plus. All right? So we already know a squared is 16. B squared is 36. When you add those together, you get 52. That's right, 50. All right, but you also got to take the square root. Oh, I said 52 and wrote 54. That's what I get for trying to be funny. Solve for c, you take the square root, take the square root. Now, 52 needs to be broken down. The square root of 52, you need the biggest perfect square, which is 4, that goes into 52. 4 times 13 is 52. That's a perfect square. That is not. So the square root of 4 is 2, and then radical 13 is what you're left with. So over here, we have 0, 0 plus or minus 2 radical 13. So as ordered pairs, they want you to write them as two separate ones. 0, 2 radical 13, comma, 0, negative 2 radical 13. All right, last problem, number 20. It says find the equation of the hyperbola. So first you want to find out who's the major axis. So what direction is the hyperbola going? It's going left to right, so the major axis is x. So immediately we know we're not choosing b because your positive variable is your major axis. All right, now remember, underneath the major axis is your a squared, and underneath your minor axis is the b squared. Well, where do you get a and b? A is the distance from the center, to vertex. And little b, all right, I'm going to show you where little b is. So let's look at a first. So from the center to the vertex, that is a distance of 6. That's little a. So remember, underneath x squared is going to be underneath x squared is going to be a squared, so 36. All right, little b is going to be the distance from the center to the minor vertex on the minor axis. So it's from the center to that, which that is 2. And then underneath y, remember it's not b, it's b squared. So when you square that, you get 4. And that is your answer. Pause these videos, stop them, rewatch them, study it. Honestly, I think parabolas, which was in the first 10, are the hardest. And circles are the easiest. next ellipse, and then hyperbolas. Best wishes on the test. I don't believe in luck, so good skill to you.